Hey everyone, so in today's video we're going to be going over Graham's law of effusion. So effusion is simply the movement of gas particles through a small hole without collisions, and Graham's law tells us that lighter gases effuse faster than heavier ones. So the equation is rate 1 over rate 2 is equal to the square root of m2 over m1, where rate is equal to the speed of effusion and m is the molar mass of each gas. So with that said, let's go over the first problem. So compare the rate of effusion of helium, which is 4 grams per mole, to oxygen, which is 32 grams per mole. So we can go rate helium over rate oxygen is equal to the square root of 32 over 4. We need to make sure that our ones match. So it would be 1 on top of the left over here, 1 right over here, and then 1 down. And then it would also be 1 down here. So we're making sure that they match. So it's going to cross multiply essentially, and that is equal to approximately the square root of 8. It's equal to the square root of 8, which is equal to approximately 2.83 rounded. So helium effuses 2.83 times faster than oxygen. Let's try another problem. An unknown gas effuses at a rate that is 0.41 times that of hydrogen gas, which is 2 grams per mole. What is the molar mass of the unknown gas? So here we're going to start off with 0.41, and that is going to be equal to the square root of m unknown over 2. And then 0.1681 is going to be equal to m unknown over 2. So then now when we isolate for m unknown is going to be equal to 0.1681 times 2, which is going to equal to 0.3362. Now just wait, we must square it. So the square root of 0.41 is going to be equal to 2 over m, which is going to be equal to 0.1681 is equal to 2 over m. And that's going to give us approximately 11.9 grams per mole. So the molar mass of the unknown gas is 11.9 grams per mole. A few tips and common mistakes to avoid: always double check if you need to invert the molar mass ratio. Use the correct units, which should be grams per mole. Round carefully, especially with square roots. And Graham's law applies to gases at the same temperature and pressure. I hope this video helped. Thank you.